Hello everyone. Today I'm going to talk about recipe recommendation using ingredient networks. My name is Chun Yuen Teng, and this is a joint work with Yuen and my advisor Lada Demic. So to begin with, I want to let you think a simple question. So how do we make a great dish? So I think most of you will answer with recipes. So, but today we not only read recipe books, we also check online recipes. So for example, like allrecipe.com, sorry the resolution is a bit low, but so in online recipe side, we can share our reviews, we can share our homemade recipes, we can rate our friends' recipes. So in this work, we will talk about our finding from our online recipes. We get recipes from allrecipe.com, and we crowd all recipes, including cooking direction, ingredients, nutrition information, and like lots of stuff. And we also get crowd all the user reviews. So now we want to ask two big research questions. So the first research question is, can we identify any pattern, or can we distill any cooking knowledge from our recipe sites? And the second is, given this, if we have ingredient information, can we aggregate it together as an ingredient network and to predict recipe ratings? So here is a framework of our recipe mining. So, first we will aggregate the information of ingredients to build a complement network, which is a combination of ingredients. And we also build a substitute network, which models the substitutability of ingredients. And then we use this information to predict recipe ratings. So let's begin with ingredients network. Now we may ask, will we mix? Maybe you will want to mix banana with blueberry, but maybe you don't like to mix apple and cones. So we can use this information to make a component, to build an ingredient network. We call it as a component network, so which is made from ingredients. And so we have two design choices to give the weights of ingredient network, which could be the raw frequency of co-occurrence, or the point-wise mutual information, which measure the likelihood that two ingredients co-occur in the same recipes. So here I want to show you visualization of a component network. So in general, we can identify three big clusters of networks. So the first one is a sweet cluster. So the first is sweet cluster. So you can see like sugar, butter, white sugar, and flour, and so on and so forth. And the other community is the savory community, which you can see is like garlic, olive oil, onion, and pepper. And the last one is mixed drinks, like you will see vodka, juice, pineapple juice, ice, and so on and so forth. And then we want to ask, can we identify, since we know how to combine ingredients, then we want to know, can we identify another relationship between ingredients? So we introduce a network called substitution network, because when we check the user reviews, we will see lots of users say, I want to replace butter with sour cream. So we can identify this pattern, like replace A with B, or you want to substitute B for A. So we can aggregate this kind of test and build a network called substitution network. So for this network, we use it is a directional network, and the weight is defined as the conditional probability. So for to define the probability to substitute. So here I want to show you the visualization of substitution network. So actually you can see there are many communities in similar. So if we run the community finding algorithm, we will see many communities. For example, the other side is the community of the milk. You will see lots of substitute relationship between milk. It includes milk, half and half, heavy cream, buttermilk, skim milk, and so on. And the other community is the cinnamon community, which you can see ginger, allspice, nutmeg, and so on. So then we come up with the other question: Why do we use substitution network? What can this for? So here we try to understand this. So we are thinking, can we tell any user preference from the substitution network? So we built the other network called the preference network. So the preference network is based on, so the edge is created from ingredient A to B if the rating of A is less than rating of B. So which, here I give an example. So say if we have two recipes, the first one, recipe X, has beef, ketchup, and cheese. And the second one is contains beef and pickles. And we know the rating of Y is less than rating of X. So then we can create two edges. One is from pickles to ketchup, and one is from pickle to cheese, which means the rating of pickle is less than the other two. So we calculate, we assign weights similar to the substitute network. We use conditional probability, and we run the correlation test, and we found the correlation is pretty high, which means the substitute network encodes users' preference. And then, after we build so many networks, we build a substitute network and complement network. What can this information for? So we design a application test, a prediction test. So the test is, say, if we have two recipes, we want to predict whether one recipe rating is higher than the other one. But actually, we don't want to. We want to compare cheese and cake, so we only consider those recipes and contain similar ingredients like this, like Mongolian beef and curry beef. So we want to ask user about this. So we have this data information, and we have include such a we have many features. Like for example, we have for the baseline information, we have cooking method, preparation time, the number of serving, and we also, we have all of these features, and we combine it together and see we can reach about like 80% accuracy, and the ingredient networks give the very impressive performance. So for the conclusion, there are several takeaway messages. So the first two is actually we built two networks which are complement network and substitute network, which model the mixture of ingredients and the substitutability of ingredients. And the last is we use this information and to predict recipe ratings, and we achieve very impressive performance. And thanks for your attention.